Insert pause for music here.
Boom. Let's see if that works.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Jenny List.
This is episode 298, Forbidden USB-C, a laser glowoscope, and the Epoch Super Cassette Vision. Hooray! Nice to have you on the podcast.
Well, thank you very much. It's nice to be here.
The first thing in the news this week is the Ryugu asteroid sample return project, and this is a really cool scientific paper. Well, they found biological material, looks like bacteria, on this sample that they kept in an ultra clean room that came back from the asteroid Ryugu. Problem is, looks like it's Earth bacteria. And so it's a really neat write-up, actually. You should go read the scientific paper. It's basically about how impossible it is, no matter what your clean room procedures, to prevent Earth life from contaminating samples that you bring back to Earth. But I can just, in my head, I just imagine these scientists from JAXA who are sitting there looking at these samples going, oh my God, there's life. And then they're like, yeah, it matches exactly the profile of our control here. It's our life.
Yes, I know this is something that we Hackaday editors have discussed in the past with respect to space stories. And I was reminded of, for many years, I've been a home brewer at home, making my own alcoholic beverages. I grew up on a small farm, and just how difficult it is to keep bacteria out of a homebrew thing. And I can imagine they're just as persistent if you have the ultimate in lab equipment. So I'm sorry if that reminded me of something very close to home, but I feel their pain having had to throw out an entire batch of cider that went wrong. And at least I didn't spend many billions of dollars getting those apples.
For sure. Well, I mean, in the end, I think there's so much more interested in, what kind of rocks this thing's made of and all of that. So, the fact that there's biological contaminants is, doesn't ruin any of the science to go along with it. In fact,
no, of course not. No.
In fact, if anything, it kind of augments it. It's like, oh, hey, look how hard it is to keep from doing this.
No, very much so.
But then if you look at the comments, everybody's pointed out that, we've sent so many landers to Mars already that I know that NASA tries to take incredible precautions against accidentally bringing life to other planets, especially before we've figured out if there is any or has been any there before. But man, you just have to know there are probably Earth bacteria on Mars now, if assuming they can still survive.
Yeah, perhaps somebody will go back to the was it Mariner landers? Which were the first landers that landed on Mars?
Viking and Mariner.
Viking and Mariner. Somebody will go back to those in sort of a century's time and probably find lots of colonies of life and get very excited for a minute before they cart the probe back to the Smithsonian, I guess.
Yeah, the write-up on this, it's at phys.org, brings up the fact that NASA actually has a strain of bacteria that lives on a cleaning product that they use in one of their clean rooms. It's one of those, like, microbial life can find a way kind of things, right? Like,
I do remember reading a paper, probably over 20 years ago. It was talking about the specific strains of, I think it was bacteria and fungi that had evolved in the conditions on Mir. And I suspect there'll probably be a bunch more papers come out of the International Space Station if they haven't already. It's evidently an issue that will vex microbiologists across space programs for a very long time.
Other bit of Hackaday news this week, we were talking about hacking the Redbox machines last week. And right before that podcast went live, we got a tip about a Redbox machine hacking wiki. And we wrote that up. There's now a wiki for hacking Redbox machines. Throw the links in for that in the show notes. Another person has since then come up and said, hey, I had a wiki exactly like this, and these people may have copied it from me. And we have no idea. We don't know who's first or can't adjudicate any of that. But I encouraged this person to head on over to the comments and leave their link too. So it may be that there's even more information out there than just what we've got.
All I can say is, as somebody living on the right-hand side of the Atlantic, I'm sorry to be missing out on the fun.
Yeah, right? Free crazy vending machines.
Every hackerspace is going to have one, you just know.
Yeah, I love what the comments on this one. They're talking about, what else could you vend in these? Because it really is tailored to the DVD format. And it's like maybe put components between a couple pieces of cardboard, 555 timers embedded in cardboard, and it could dispense 555s for you. That'd be hilarious.
Almost every hackerspace I have been a member of has either had a vending machine, whether it's working or somebody's project, which will work one day, or has decided they want one. But I don't know that I've ever seen a hackerspace that actually successfully vends, in that you can walk up to the thing and you can buy an Arduino. But by my observation, not many people actually do that. It's just one of those things it's cool to have. So there's probably a question in there. What is the justification for actually having a vending machine in a hackerspace other than it's cool?
Well, they're selling the wrong things. Munich Hackerspace has a drink machine that they've hacked to run on their own. They have like an internal currency and credit system. And so they've completely redone the electronics to allow you to vend off your points with it.
I wasn't thinking of drinks vending machines. I know more than one hackerspace who has one of those that's been hacked. I was really just thinking the usual, I can buy a breadboard or an Arduino or some other useful piece of hacking stuff.
The problem is when you're in a hackerspace, there's always somebody who's going to just give you the Arduino you need, right?
Well, there is that. Yes, it's usually me in my hackerspace.
Hey, does anybody have a blank? And somebody will come up with it. It's kind of creating a stocking problem when it's much easier to just say, hey, lend me this cable. But I know what you mean, but they're so tempting, right? Like it's an awesome piece of functional machine.
I mean, everybody wants one.
Well, and that brings us to what's that sound?
Woo.
This is a journey into sound.
What's that sound?
What's that sound?
Oh, this week I actually have one, Jenny, that is exactly tailored for you.
Gosh.
This is not the guarantee that you're going to guess it correctly, but let's give it a look.
Okay, I will give it my best shot.
Any clue?
I'd love to be looking at this on a spectrum analyzer.
Right?
If I had to guess, I would say that it was some kind of slow scan television or similar radio format, but it's not one I've heard before.
Not bad, not bad. It's not one I'd ever heard before either, and usually I pick the sounds knowing what the sound is, and then I go out to listen to it, and this one I actually stumbled on it and was like, wow, that's the craziest thing I've ever heard. It is Eurosignal.
What's that?
It is an old school pager broadcast that used to use the bands at the very low end of the FM radio band.
Okay.
And I know they did it in Germany. I don't know if they did it in other places. Let's go look at the Wikipedia for it.
I don't think we had it in the UK, otherwise I would have recognised it because I was an inveterate radio listener through entire 1970s through 2000s. So I think if I'd heard it, I would recognise it.
Wikipedia says Germany in 1974, France in 1975, and Switzerland in 1985. And it was running until kind of the late 90s. Those different tones you hear, it uses them to encode, of course, different numbers. And apparently everyone's pager had its own particular ID number. They send that out, and then they send the number that you're supposed to call. But because this was way down at the low end of the FM band, whatever, Wikipedia is saying they had 4 channels, kind of 87 megahertz-ish. If you had a radio that would let you tune down there, you could actually like listen to them live as they were going off. Really fun.
Well, I certainly did have a radio that could do that, so I can only conclude that they weren't broadcast in the UK in the 1970s, which evidently I missed out on a formative hacker experience.
If they were in France, I wonder if you could have heard them from there?
If I had been on the south coast of England, almost certainly, but up in rural Oxfordshire, no chance.
Well, this one brought out a bunch of Germans who guessed it correctly, it looks like.
Oh, that's cool.
So, 15 answers? This was a tough one. Like I said, I didn't know it. We have 15 answers, and of them, 5 got it correctly.
So who's the winner?
So let's see. So 5 is easy. I got a 6-sided die. Let's see who wins. Two. Ah, congratulations to Nicholas. Sounds like the Eurosignal, the soundtrack of my childhood when I was playing Space Lego in the 80s, tuning the radio to the end of the scale.
Well,
That's awesome.
congratulations, Nicholas.
One of the other right answers actually comes from Henner Zeller, who did a really neat hack that we covered last week, which was the glow-in-the-dark watch thingy.
Oh, that was him, was it? Oh, cool. Yes, that was a very cool hack.
The dice did not favor him, but sounds like pager notification sounds. I remember it being broadcast around 88 megahertz at the end of the FM radio band is about the right answer. Like I said, I'd never heard it before. Sometimes even I learn something on What's That Sound. So congrats, Nicholas. I will shoot you an email, get your t-shirt size, and get you one in the mail shortly. Everyone else out there, stay tuned next week when we'll play another sound and you'll have your chance to guess. All right, well, let's start up the hacks. This week I wanted to start up with Angus from Maker's Muse. Would an indexing feature benefit your next hinge design? And the indexing bit is a really neat trick that he throws in at the end of this video. But honestly, this is a 10-minute video showing you everything you need to know if you're 3D printing about designing your own built-in hinges. And it's just an absolutely fantastic watch. He starts off with what he calls the butt hinge. And this is, the one you're thinking of when you think of a hinge. It's got kind of a U-shaped bit and then a piece that fits in there and a pin going through it. It's the one that people usually do print in place. His first point is that often just leaving these as holes and driving a screw through it is much more reliable. It makes the tolerances easier. And it makes it so that you can back the screw out, take the thing apart, and re-screw it back together later. It's funny to hear him, a 3D printer maniac, a guy who pushes crazy 3D printing designs, to be saying, don't think so hard about the print-in-place hinge. But there you have it. He then starts to talk about the print-in-place hinge as we know it, and has a couple really neat tricks, including using a flat bottom for the pin because it makes that bridging that it has to do easier because it's got a longer area. If you think about a circular pin, right, it has to run one thread and then two threads on top of that and three on top. That's kind of asking for droop. And instead, if you just shoot like a flat bottom across, it helps a lot. And similarly, when you're printing the hole, there's an old rep wrap trick where you make a teardrop at the top so you don't have that really flat overhang at the top, which also is hard to print.
Yeah, that makes sense. That's a good idea.
Yeah, so it's a really cute couple small design tips to how to make print-in-place hinges better. But then he suggests a couple other different hinge designs that are much more robust and don't worry as much about the tolerances of your 3D printer, like a snap hinge, which is really cool. It's basically just got a couple nubs on the outside of one piece that fit into little holes on the piece that it snaps into. And the nice thing about that is that, if you taper the walls on the nubs and on the holes, they kind of automatically snug themselves together. And if you can handle it being removable, which sometimes is a benefit, it definitely makes for a better fitting hinge. And I think that's really cool too. He talks about living hinges, which are you just fold the plastic. That kind of never works very well with 3D prints because the plastic fatigues pretty quickly. But then the last one, and this is the bit that got the name for our post, is these indexing pins where you make the pin in the center have a rectangular profile, and even though the hole around it is basically circular, but then you can kind of cut a slot out so that the rectangle can fold in there. So you can get a hinge that folds, but you can also pull it out and it locks into place. And he demos this by making an awesome, cute little GoPro tripod that you can fold up and then unfold and lock into place, which is kind of cool. He also adds his tapered angle hinge to this one design just to show off, I guess. But what he doesn't even mention, and this totally made me crazy, is the GoPro hinge, which, he's attaching a GoPro camera to it. And that one is this, how it's got those kind of interlocking fingers.
Yeah, the three fingers. Yeah.
Yeah. And then you tighten it together with a bolt that runs through. And that's a fantastic one to have in your 3D printing arsenal as well.
Oh, definitely. My microphone sitting in front of it at the moment is on a 3D printed home designed stand that is all GoPro hinges.
One of the first designs I ever shared publicly was a fan shroud for RepRap printers that used the GoPro hinge because, it's just exactly what you need when you need something that you can bend around and then lock in place.
I might have to hand back my golden wrencher for this and was forced to walk away in shame. I think print in place is an incredibly cool thing you can do with a 3D printer, and we've seen some wonderful 3D printed items that have come out of it. Probably one of the first things I remember seeing way back, sort of 10 years or more ago, 15 years ago, was the first time I saw somebody did a print in place. You remember the Möbius strip gears that would work, and you could only
Oh,
print them in
yeah.
place. And they're beautiful. And since then, we've had ever more intricate devices come out of it. And these hinges are a brilliant example. Now, here's where I'm going to have to hand back my golden wrencher. I think sometimes our community does print in place for the sake of it. And maybe it's something to do with being a blacksmith's kid, but I like to make the parts separately and assemble them because then I'll probably get a better result with something intricate. That doesn't lessen my seeing print in place as cool, but sometimes you just need to do what you need to do to make something that works. Come on, tear me apart in the comments.
The whole series of like articulated animal things, and it lets you do things that you couldn't do otherwise. And so there
That's true.
is definitely a case for it. But you're not wrong. Like the first 5 years, 6 years of people doing print and place hinges was all just because you could.
Exactly.
It's just so cool. And I think actually that's something that Angus starts off this video kind of swimming upstream against, right? He
enough,
does
that's true.
say, it's easier to get better tolerances sometimes if you just run a pin through it. Get a piece of metal, run it through the middle like you should. And I do have some sympathy for that. Print and place is still so cool.
No, next up is a gloriously missed opportunity from the 1980s console world. It's a Japanese console that came out just after the Nintendo Entertainment System and the Sega Master System, and was meant to be the next big thing from its manufacturer, but completely missed the mark by simply not being as good as the two big sellers of the 1980s that we've all heard of. I'm talking about the Epoch Super Cassette Vision, which was a console that, if it had been released 2 years earlier, would have wiped the floor with everything. It had multicolor sprites. I think it had unlimited sprites per scan line, and it could move sprites around. But the rest of its capabilities were woefully inadequate compared to the Nintendo or the Sega. In particular, it had a sound chip, which was taken from a handheld game, the little late 1970s handheld games that made beeps and boops. And when the competition had full synthesizers, it sounded woefully bad. It's always interesting to see the dead ends in the world of consoles, because there are plenty of them. Their previous console, which was just the Cassette Vision, was a big seller in the early 80s in Japan, and overnight they went from being leader of the market to being nowhere behind Sega and Nintendo. The previous console, the Cassette Vision, not the Super Cassette Vision, is actually quite interesting in its own right. We're used to a console being a computer into which you plug a ROM, or in the case of some of the later SNES games, the ROM actually turned out to have some DSP and other chips in it. But the Cassette Vision looked like that, but in fact, each cassette had a programmed microcontroller. In effect, they'd taken the guts of the late 1970s TV games, which had moved on from being a sort of specific logic state machine for Pong and the like to being a microcontroller, and they'd stuck different microcontrollers with different games into cartridges. So, in fact, every cartridge contained its own NEC MUPD 774C microcontroller. So both those consoles were consoles I'd never heard of, and were just sort of fascinating sort of footnotes in the world of 1980s consoles. So that caught my eye.
That is a crazy machine. I've never seen this ever before in my life.
I think if you're not Japanese, you wouldn't have.
But of course, someone comes up in the comments, stop. Trivia information, this game console had the first Dragon Ball themed game on it.
Impressive.
See? It must have been really interesting back then when all of this was kind of, the Wild West, right? Like everybody was rushing to put microcontrollers into a plastic box and have it be a video console. I love the idea of having the full game on the plug-in cartridge.
Funnily enough, in that period where I grew up, we kind of missed out on the console thing because we had an enormous home computer boom, which was led at the lower end by Sir Clive Sinclair with the ZX81 and then the Spectrum, which really meant that it was later in the decade with the Sega and the Nintendo when consoles really took over, because having a proper, well, as if much as a Spectrum is a proper computer, having a proper computer was simply cheaper than buying an Atari 2600 or something. So I kind of missed out on this completely growing up in the UK, just from having a slightly different path through home computing.
That's cool. Next up, Bitluni, a laser with mirrors makes a CRT-like display. And I don't know what to think about this one. It's such
I
a
love it.
beautiful end product, right? Yeah.
It's beautiful.
It looks like it's intended to look like a little scope. It's got a curved screen made out of 3D printed glow in the dark filament. So it responds to being hit by a UV laser. And then in the back, he has two stepper motors trying to flip mirrors around like they're galvos and shoot the laser out at the screen. In kind of true Bitluni fashion, he takes this idea and pushes it as far as he possibly can. And the result is it's 3D printed. It's absolutely lovely. I saw this and I've played around with laser light show systems before, and they have those stepless galvos that go incredibly fast. And I've seen a bunch of hacker projects like this where they try to do the same thing with stepper motors, and they're just ridiculously slow in comparison, and they've got the steps in them. And there's this one beautiful scene where he's developing this and he gets it to finally like draw a square, and he's like so stoked and he's like, it's a square. And you can see the steps from each individual step in there. But then he gets it to do micro stepping and slows it down so that he has enough control over it and gets a fantastically good looking result out of it. And I think, yeah, I have to say, he plugged at it so hard that he made something that shouldn't look this good look this good, and I just absolutely love that.
Every time I see a project of his, he knocks it out of the park, and this one in particular is, as I said earlier, simply beautiful.
For sure. And it's totally cheating because he likes to play around with vector graphics and stuff. And so he has this whole like backlog of experience to build on. And so he just like shoots up some cool looking images on it. But the end product has like an entire menu system. It's got everything. It's such a cool little project. It absolutely makes you want to build it. And it's pretty straightforward. Like he just uses an off-the-shelf Pololu style, plug-in CNC multi-axis stepper driver. You can pick these up on eBay for like $10. And it's a regular laser pointer, and it's a couple mirrors that he cut up out of scrap he had lying around. Like this is totally something you could do. You'd have to source the glow-in-the-dark PLA to print out the screen with, but that's really about it. The little BNC jacks he puts on the front are just like such a nice touch.
Yeah, I like the way that the screen is curved. He didn't actually have to do that. He could have just printed it flat, but he's gone to the effort to make it curved, to reduce the distortion, and to just make it basically look like a television should.
Bitluni ends this video saying, "Don't worry if you want me to order some proper galvos. I've done that already, and that's going to be my next hack coming up." And I'm super stoked to see that.
Try and persuade him to bring it to Hackaday Europe if he's coming.
Ooh, yeah, we'll have to see it in the flesh.
The next one touches on a piece I wrote as a bit of a rant a while back in an OC. It concerns flyback high voltage generators. Now, a very easy way to get hold of a high voltage transformer is the flyback transformer from a TV set. There are a lot of circuits out there which claim to be a flyback converter because they use a flyback transformer, but in fact they're just driving the ferrite of this transformer with a free running oscillator with a pair of enormous power transistors and dissipating vast amounts of heat. And they're not a flyback converter at all. Now, to explain what a flyback converter is, imagine that the core of a transformer is a store for magnetic field. And if you build up the current in the primary of a transformer very slowly. You build up an enormous amount of magnetic field, and then if you cut off the current very suddenly, that magnetic field collapses very quickly and you get a huge pulse of energy. And that's the so-called flyback. It's called a flyback because it was originally used in TV circuitry, and the collapse of the magnetic field happened as the spot flew back across the screen. But it's a particular type of switch mode converter which is designed to very efficiently make high voltages without basically wasting power and heat in the transistors and stuff, or heating up the core by saturating it. And it's been a bugbear of mine for ages that there are all these so-called flyback circuits which aren't flyback at all. And along comes a guy called Alex Lungo, who has finally made a proper flyback driver for TV flyback transformers. And the way he's done it is he's used a switch mode power supply chip, a Texas Instruments UC3844, which isn't one I've come across before, but seems relatively conventional, driving the flyback transformer through an IGBT. I have to say, that in itself is interesting. I would have probably nicked a flyback transistor from an old telly, but that's just me. The interesting thing is he's driving it at 25 kilohertz, assuming it's a television one and not one out of a VGA monitor or something. I'd expect the transformer to be happy around 15 or 16 kilohertz. I cannot, off the top of my head, remember the frequency for NTSC, but for PAL it's 15.625 kilohertz. I'd be interested to know whether 25 kilohertz is actually efficient with those transformers. I'm just my sort of parts nerd interest there. But it's so nice to see an actual flyback board for driving a flyback transformer. So I congratulate him on this one, and this made me happy. It's the heartfelt rant of somebody who grew up fixing old televisions from dumpsters.
My next hack comes from, I don't actually know his name, but he is the guy behind Stargate System. This is DIY Pipe Inspector, goes where no bot has gone before. Starts off with a difficult story of home ownership. His parents' sewage pipe is blocked, and they send a company out to clean it, and they do, and it's blocked up again a year later, and they send them out again, and it's blocked up a year again later. And the reason is the pipe splits, and the place it splits in two. One of them goes off at a 120-degree angle, so it takes a rather steep curve. And the pipe inspection company, when they come out there, they run a camera on a cable, and it has a blind spot exactly where this tight bend is. If you imagine, trying to push a spring through a pipe, right? And it takes a little bend, but then there's an even steeper bend. The spring is going to follow the radius of the outer bend no matter what you do. And it just never saw where the blockage was. Of course, the solution is to build your own little pipe inspector robot.
Of course it is.
On treads that can drive in there. And I love this because this has the weirdest constraints on it. Little robot has to be waterproof. It has to send video back, so it needs some kind of comms. It has to be small enough and agile enough that it can make this 120-degree turn when it comes to the right place in the pipe. And so those are kind of his constraints. He'd already had a small wheeled robot that was almost the right size, and he converts it to tracks in this video. There's a bunch of neat details here. It's got a Raspberry Pi Zero in it and a camera. He waterproofs the thing. It's got an Ethernet cable that connects it back to his real computer, back outside of the pipe. What I think is cool is he runs power using power over Ethernet to this little thing. So this one cable does it all. Then he drives it in there and, lo and behold, this closed off 120-degree blind appendix is exactly what's been giving him the problem. He then goes in there and chases it with absolutely the scariest homemade sewer cleaner adapter thing I've ever seen, which is just a bunch of links of chain spun around on a spinning stick. Absolute nightmare. But he goes and gets rid of, all of the crud that had built up in the dead end, and then goes exploring in the rest of the pipes. If you are a little bit queasy when you see these things, try not to think of it being a sewage pipe. Other than that, it's an absolutely beautiful, very purpose-built little rover build. And I just love the idea of sending these things into places you can't normally see. Like he's testing it out at an early part of the video in his kitchen and running it underneath the floorboards under like his under his dishwasher and stuff like that.
I would be particularly worried that it would break down and become a fresh blockage in the pipe. But yes, it's a beautifully built machine.
I guess you could pull it out by its Ethernet cable, unless that's what broke, right? Now you have two problems. Excuse me, you have a robot stuck in your sewage pipe.
Yeah, I'm sure there would be a drain inspection and cleaning engineer with a particular tale to tell. There was a story this week that tickled a fascination I have with integrated circuits from the first decade of mass market commercial integrated circuits. And there is a certain number, I mean the 555 or the 741 or the 723 voltage regulator, which has survived despite being massively outdated or superseded. Another favourite, I think I wrote up a piece about it, is the 7400 quad NAND gate. Now, of course, the original 7400 has been superseded by many chips that replicate it, so you can get a 7400 in all sorts of weird and wonderful logic things. But there's another one which you'll find in all sorts of places because it's just simply useful, and that's the TL431. Now, if you haven't seen a TL431, it's a little three-terminal device, looks like a transistor, but it's actually a bandgap voltage reference. It's an adjustable voltage reference. You can think of it as a adjustable Zener diode, which is usually how it's featured in a circuit diagram. And there's a guy, the enigmatically called Kevin, he doesn't have a surname, who has done an investigation of the TL431. He sort of goes in how he uses it for all sorts of places where you might use another more modern component. And I'm totally with him here. It's a very versatile part. The thing I like about the TL431, if you download the current database from TI, it's very boring. It just talks about it. You can use the voltage reference and shunt regulator and all the things. But if you find one of the early data sheets for it, one from probably the 90s or before, you'll find the original data sheet, which has, it's got an ohm meter, it's got all the power supply things. But then, of all things, it's got an audio amplifier and a switch mode power supply wiring up as part of an oscillator. If you're curious about the audio amplifier, it's quite an old-fashioned circuit being used in series with the primary of a high impedance transformer that drives a low impedance speaker. But somebody, when they were designing this circuit and writing the data sheet, thought, hey, I can use this as an audio amplifier. I just love that. It's the kind of thing you no longer see on data sheets. But anyway, if you have the need for an accurate voltage reference, check out this article. And if you're looking for a TL431 to play with and you can't be bothered to order one from Mauser or whoever, if you open up most slightly older PC power supplies will have one in somewhere. So there you go. Get out your desoldering gun.
I love the TL431. It's funny. I actually wrote up an article ages ago, Ode to the TL431.
Oh, I missed that.
Yeah, well, I'll throw the links in the show notes for you and everyone else. Ken Sheriff also does a nice teardown of one. I'll throw that into.
Well, that's good.
It is like you say, it's a tremendously versatile part. I never understood this programmable Zener diode thing. For me, it's much easier to just think about what the thing actually does, which is, it compares to 2.5 volts. And if it's higher, it conducts. And if it's lower, it doesn't conduct. That's the Zener action, right? And programmable means you can put a voltage divider in there on the 2.5 part and knock your 5 volt threshold down to 2.5 to fit it, or if you want it to turn on at 9 volts, you divide by whatever that is in your divider string. Like, it's always been a strange, to call that a Zener is always been really kind of strange to me, and a bunch of people show up in the comments and agree. What I think of it as and what Ken Sheriff shows it to be by having a look at the die is exactly what it is, right? It's a band gap reference and a comparator, and then it compares it to the voltage you spit in. That kind of demystifies it a little bit in my mind, but it also makes you realize just how useful the thing is. Actually, the circuit I pointed to in my article was a all-in-one battery charger that uses it to bring a lithium iron phosphate battery up to its charge voltage. In the same circuit, lights up an LED when the charge has been reached, right? When it's charging the battery, it robs the LED of its current, basically. And then once it's done, boom, LED lights up. 3 parts, I think, 4 parts, maybe counting a couple resistors to set the charge, set the end of charge voltage, and that's it. Really sweet, really cool little part. And like you said, you can make an amplifier out of it.
Yeah. I'm not sure I'd like to make the switching converter, though. I suspect it would produce vast amounts of RF in places you wouldn't want it.
Back in the day, you could get away with that. My first quick hack this week comes from Tough. Homebrew phosphorescence detector looks for glow in everyday objects. This is, on one hand, a really simple idea. It's a bunch of UV LEDs and a photodiode in a light-proof metal can. You shine the light on it and you look through the photodiode and see how it glows. This, plus some really nice low noise circuitry, gives him a sensor that can tell kind of in a millisecond resolution how much things glow after they get hit by UV, and goes around looking for household objects that you can put in there, and of course finds only the usual suspects, glow in the dark things, etc. But it's really nice because it gives this beautiful kind of exponential decay even over the shortest time scale on whatever uncommon glowy things. Fun project. Next up, Donald Papp wrote a piece for us. Your undocumented project may also baffle people someday. He's riffing on the Dorchester County Historical Society in Maryland had this machine and they were speculating what it is, and it looks like it's a particular kind of biscuit dough rolling machine. But I love Donald's take here that, if you've also failed to document your projects, maybe someday a historical society will be looking at this saying, what is that thing? And last up, Arne, e-ink screen combined with analog dial is epic win. This is just a fun little hack. If you think about those old school analog like multimeters or whatever, where you have a little red needle that goes back and forth, the background is usually a piece of paper with the scale written on it. Here he replaces that with e-ink so that you can have the display configurable in what units it's displaying in or whatever. The dial mechanism is still analog, but the background scale is on e-ink. I just think it's such a funny idea and such a blend of the two. You could have this be, analog dial meter for anything you want, and you can change it on the fly. Not a need I have, but it's a need I want.
Okay, my first quick hack is a piece I picked up. A friend of mine, Dominic Morrow, talking about how to get started in laser cutting. It's an interesting talk, and you should definitely watch it, because a lot of us, we see laser cutters in our hacker spaces, but because it's still quite a complex piece of kit to own, coolant and fume extraction and all stuff. Many of us don't have one at home, and he's trying to demystify it and tell you how you can get started. We all know that the hacker camps, big hacker camps in the summer, they have lots and lots of talks and they record them, and sometimes it can take them a very long time to get them all edited. I don't blame them for that. Their volunteer run, it's a huge task, but I'm very pleased to see the electromagnetic field now at the moment uploading a whole load of ones from last summer. So keep an eye on that if you want to find some new talks. I know I will. The next one was one that rather interested me. And those of us who've made printed circuit boards, we've all made mistakes. We've got the wrong footprint or the footprint the wrong way round or something like that. And few among us have not at some point had to do a rework or a second spin of the board. And it's gratifying to find that it can happen to the best of us, the most accomplished electronic designers. And for that, I give you the Apple LC3, which was a Macintosh from the early 1990s. I actually remember I worked on a site that had a whole load of these. It was rather nicely designed, a whole series of them that used the same case. It was, you opened it up like a pizza box, and inside all the parts were laid out like a TV dinner. It was just very well designed. But the LC3, which memory serves me, had a 68030. I'm sure people in the comments will correct me if that's wrong. It had 3 capacitors for the supply rails. I think they were plus 12, plus 5, and minus 5. And there was a legend that Apple had got one of them the wrong way round. What the Apple engineer had done is they had put the 3 footprints next to each other, all the same way round, with their negative side going to the ground plane, as you would expect, and then hooked them up to the supply lines and walked away. And of course, one was hooked to the minus 5 line, and so that capacitor was the wrong way round. And on pretty much every Mac LC3, it leaks. Now, The interesting thing there, of course, is that if every Mac LC3 had a leaky capacitor on the minus 5 volt line, how come every Mac LC3 also worked? I remember using Mac LC3s, and they weren't the fastest computer of the day, but they certainly worked. I suspect what was probably happening there was that the minus 5 volt line had enough capacitance elsewhere to perform adequate smoothing, so the circuitry wasn't too compromised by it. And presumably the failure mode of the capacitor was something that didn't grab too much current and pull it down, and didn't otherwise kill the computer. But my entire life I've been told that if you connect a electrolytic capacitor the wrong way round, very bad things happen, and apparently not very bad things happened in this case. Finally, a very nice little piece of 3D printing, kind of couples in nicely to the analog meter with the e-paper display behind it. If you've ever had to mount one of those little OLED screens on a front panel, you'll know that cutting out the hole for it can be rather difficult unless you have some CNC machine to do a perfect hole. And somebody came up with a beautiful hack for it, which was to make a 3D printed enclosure for it, which mounts in a very similar way to a old-style panel meter, and for which you only have to drill a relatively easy single round hole, which you can do with a drill press or similar. I rather liked that. I don't know when I'm next going to use it, but I know if I have a project that uses one of those displays, I will certainly look very hard at this particular thing. And those are my quick hacks.
Quick hacks.
And that brings us to our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week I wanted to pick Arya Voronova's USB-C for hackers reusing cables. And I wanted to pick this because Arya's been doing a bunch of cool deep dives into USB-C where she goes into the signaling protocols, and if you want to use the power delivery, how the cables have E-tags in them, and negotiate with the device to say how much current they're capable of carrying, and then the devices talk to each other and say what voltage they want down the line, and it's got an active signaling thing, so even if you're not asking for an esoteric voltage, the device still has to be able to talk back to the host, etc., etc., etc. Forget all that. This is a really neat look at just using the cables as what they are, cables. Because USB-C cables are kind of ubiquitous, and we can get USB sockets everywhere, and they make just a great, simple cable if you're willing to reuse / completely abuse the USB standard if you need 5 or 6 lines between here or there. And I really like that idea, and I can't believe we don't see more people abusing it. And then I thought, oh, but wait, we have. Way back when, and I remember being absolutely appalled by this, the cardio badge from, which camp was that? 2019 Chaos Communication Camp was using the extra lines in USB-C to hook up to sensors. It was the badge had a functionality where it could do heartbeat detection, and they were actually hooking up, those gel pad chest sensors and arm sensors to the extra wires in it. And at the time I was like, this is totally wrong. This is an abuse. And now I'm 100% behind it. I think it's absolutely fantastic. And so I've come around. But Arya's point is that some of these cables are meant to carry, lots of current. And so if you need 5 volts or, kind of 240 watts, it's amazing you can push that much through these little things. There it is. You've got the cable, you've got a connector that's meant to connect to it. It's all there for you. Just cut them up and use them. And I just think that's such a lovely, sweet, hacky idea that it's fantastic. That, it's something that I'm probably going to end up using because, those big pin headers, you can make your own special cable out of those pin headers, but it's just stupid. USB-C's everywhere. Lovely. She ends up with passing HDMI over USB-C cables and some other dirty hacks, which point out the other thing that USB-C cables are good at, which is some of them are designed for extremely high bandwidth data transmission. So on one hand, you've got 5 or 6 connectors if you need them. You've got high bandwidth if you need that. And you've got power. You've got the ability to transmit a pretty reasonable amount of power over the cables too, if that's what you look at. And all three of these, plus the fact that you've probably got a bunch of USB-C cables in your junk box right now, makes this a really cool idea.
Finally, maybe we've proved the famous XKCD cartoon about 15 competing standards wrong. The new standard does do everything.
I will note that a bunch of the people in the comments do come in and say, this isn't USB-C anymore. And Arya mentions that in the article. You totally want to label them. If it's not USB-C, you want to label this otherwise. Because the USB-C standard has this negotiation thing, they're meant to be flipped, right? Upside down.
Yeah.
And that's all done electronically. That's all done with multiplexers on the device. And so it's not like the wires magically reorient themselves or anything. And so if you're using it in a way that isn't flip safe, you really need to mark the top and the bottom of this thing. And, you know, Arya has all of these complex solutions. I would just take like a white Sharpie and mark the white side, top on the socket you're plugging it into and top on the cable. And just remember to plug it in right.
I know somebody in the badge community who has produced a USB-C device from hell that if you put the cable in one way, it appears, I believe, as a disk drive, and if you put it in the other way, it's a serial port, which is endless fun. I have to say, if people are complaining that this isn't USB-C, they are, of course, right. It isn't USB-C, but they maybe should look again at the definition of the word hacker. This is the essence of hacking.
Absolutely. And but use your USB cables however you want. Don't let anyone tell you otherwise.
Now, my Hackaday colleagues will all know that I've suffered from audio issues on my Linux install in the past because every week we have a Hackaday editors meeting, and frequently I have appeared either with no audio, with far too much audio, or I can barely hear them. And Al this week took a look at Linux audio, which I hope I'm not going to tread any toes if I say it's a bit of a mess. There are many different competing standards and pieces of software designed to make sense of it. And obviously for some people it works very, very well. In fact, the really annoying thing is on my main machine, it doesn't work, but on the machine I take around portable with me when I go around the continent to hackerspace and hacker camps, it works perfectly. So that's a very interesting read. If you too are suffering from the same Linux audio problems as I am, you can either get angry and buy yourself a Windows machine, in which case it'll work, or else soldier on with open source and hope that something will get better with the software situation in the future.
I disagree entirely. I find Linux audio to be absolutely fantastic and lovely. And I think, Pipewire is part of it, actually. I used to use Jack on things. So Al kind of brings this up in the article. There's a hierarchy. ALSA is the lowest level driver that talks directly to sound card. And then above that, there's kind of some user space drivers in the Linux sound world. One of them that was aimed at low latency and music applications was called Jack. I don't use it anymore, but it still exists. It follows the kind of patch bay style idea, that is, you can take the audio from here and plug it into there and split it into this stream and that stream. And that's kind of what Pipewire took over. For a while there was Pulse Audio, and if you hate Linux audio and Linux audio utilities, here's my rant. It's Pulse Audio's fault, because I have had problems with Pulse Audio like you could never believe. And so I always just ran everything on Jack because it was rock solid, if crazy and obtuse to configure, but at least it always worked. Or straight on the sound card itself using ALSA. And these days, I am totally happy with Pipewire. You can do all the same tricks. It pretends to be a Pulse Audio server as well. So all of your software that wants to talk to Pulse Audio can be completely happily fooled into working with Pipewire. And then if you want to do something fancy, you have kind of the flexibility that you did with Jack before. You can route the sound from here to there and from there to there. And every once in a while, like, you run into these websites where they won't let you record audio from a video or something like that. I remember having to do that using funny ALSA config scripts back in the day. And it was horrible. You have to make a fake device and do that in a loopback. It was awful. There are like happy, gooey little interfaces that make doing that absolutely simple these days with, among other things, Pipewire. So I'm as happy as I could be with the state of Linux audio right now.
Well, I think I have been down every rabbit hole of getting Pipewire to work and all the interfaces and tweak tools. And I run a fairly vanilla Manjaro Linux distribution, and it's on a ThinkPad, so you'd think it would work. But for some reason, I have had nothing but pain on this machine. Everything else is great. I've used Linux for a couple of decades now, and I first installed a Linux distro in the early 90s, for God's sake. But everything else is great. But for some reason, Linux audio is a world of pain as far as I'm concerned.
When you say laptops and old IBM ThinkPads, I had one. They had some crazy idea in their head that it was a good idea to have the microphone. They have one headphone input on it, and it does double duty as a microphone input, and it does some kind of on-the-fly switching between the two of those. And until people had kind of reverse engineered that whole mess, like that was a disaster on my old laptops.
In this particular case, I don't use the built-in sound channel on this laptop. I actually use an external sound card and a big analog mixer, but I'm still in pain on this one. So, proof in case you needed it that Hackaday writers are not gurus when it comes to everything we write about. We have probably worse problems than many readers do in some cases.
Well, that's it for this week's Hackaday podcast. Thanks very much for listening. If you want to follow the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, shoot us a line, tips@hackaday.com. And until next week,
eat, sleep, hack, repeat. Okay, well, let's give this a try, see what happens. Okay, I'm ready to go.
The first thing, sometimes you just gotta know when to hold them and know when to fold them. And I'm gonna take my next hack here. What is it called?
You can put an erratum in.